Hey guys, here's your video on what we're going to be doing in Chapter 4. I hope you all did well on your test today, and I should have that grade later tonight. I want you to look at Section 4.6, because Section 4.6 kind of summarizes the first 5 sections all together, and I'm going to try to do them all in one shot for you. And I'll do 2 examples right from 4.6. Then we'll do 4.7 and we'll be done with Chapter 4, because I really want to focus the majority of our time on Chapter 5. But 4.6 really describes the graphing process, and what is the graphing process, and how derivatives relate to that graphing process. So let's just go through a problem. I picked number 18 out of the book. I picked one that wasn't too hard, and then one that was much more difficult, number 33, which I think you're going to have questions on if you do all the homework. Your homework is going to be page 253, numbers 1 to 33. Try to do the odd ones. If you do the even ones, stay away from number 24. You can't really solve for x-intercept for that one. There's certain functions that you cannot solve or find the zeros of other than graphically. You can't solve them algebraically, and that's one of them, and I'm not even sure why they put that one in the book. I mean, we can still graph it, we can still find out a whole bunch of things, but algebraically we can't find the x-intercept for it. But in any case, I kind of color-coded these so you can see how they go, and it might take a little bit long. We might have like 2 10-minute videos, but the first thing we want to do is we want to find the x and y intercepts. And you find the x-intercept by putting a 0 in for y and solving the equation, and we got these 2 numbers. You can pause this and look at this later. I would suggest that you work your way through this if you forget. The x-intercept is just by putting... the y-intercept is just by putting a 0 in for x and solving. So there's a y-intercept at 0, 0. Then what we do is what we call the first derivative test, because we want to find what we call critical points. The critical points on the graph are the points in which the graph changes direction from increasing to decreasing, or from decreasing to increasing the other way around. The way we find those critical points, and I use green for this, is by taking the first derivative, setting that first derivative equal to 0, and then solving it. And we got these 2 points. I suggest you pause the video and look through this. Okay? The next thing we want to do is, so far, let's just take a look at this graph. So far, I'm going to graph my x-intercepts, my y-intercepts, the blue one, the pink one, and the green ones. So I got blue and pink here in the middle at 0, 0. And the green, I found out these are my critical points. So I got these 3 done. So the next thing we want to do is we want to find what we call the points of inflection. And I use the gold marker for that. And get the points of inflection, we do a second derivative test, which is we take the second derivative and we set it equal to 0. And then solve that, and I did that, and we got these points. So you might want to take a look at that and pause the video again and see where that came from. If we put those points of inflection in, they come out right here, these gold parts, these gold points right here. The question is how does this graph go from here? After we get the first derivative, we get the first derivative set equal to 0. That's how we get our critical points. And then we can find whether those critical points, the green ones, are maximums or minimums. And we find it by, if we test a point in the first derivative on either side of the critical points. If it's positive, that means the graph is going up. And if it's negative, it's going down. And you should pause the video and try that. So for this one, if the critical point happens at the point... what did we say the critical point was? Where's my paper that I had that? Oh, it's so... Jeez. Where'd it go? Here it is. My critical point, oh, that's number 33. Hold on. I'm going crazy here. Oh, my critical points came out to be 0.866. We want to take that point and test it in the first derivative. Anything to the left of that. So we'll go maybe if we go to the right of this, 0.1, and we put it in here. I mean 1, and we put it in here, and we're going to get a positive value. If we get a positive value, then it's increasing. If we get a negative value, then it's decreasing. Look at our graph. If we put a 1 in, which is just to the right of our 0.866, so this point comes out to be 0.866 and 1.125. This one's a negative 0.866 and a 1.125. So if I check out a 1 in here, which is slightly bigger than this, if it comes out positive, that means the graph is going up. But if you put a 1 into that first derivative, which is right here, you can see that it's going to be negative. That means after or to the right of this critical point, the graph is going down. If we take a 1/2, or anything to the left of here, and we test it into the first derivative, we find that we would get a positive. That means the graph is going up. If it's going up to the critical point and then going down, that means that critical point is a maximum. This is a maximum, which this one also turns out to be a maximum. This one, my test points would be, say, -1 on the left side, and you'll find that if I put a -1 in to the first derivative, you're going to get a positive value for the first derivative, and that means the graph is going up. If I put in a -1/2 into the first derivative, it will come out negative. That means the graph is going down. So I have my intervals. The interval is the increasing, decreasing interval. So let's see, if I put an increasing interval, it would increase from -infinity all the way up to that critical point, which is 0.866. Not including that, because once it peaks at that point, it's neither going up or down. Now, it is now decreasing then from -0.866. It decreases all the way to 0, which 0 is another critical point. And if you could check the areas in between the critical points and on either side, you'll see whether it's going up or down by whether you get a positive or negative into the first derivative. It's also decreasing from this critical point, which is a positive 866, all the way out to infinity. So it's decreasing here. And the graph is increasing from 0 to the next critical point, 0.866, where it turns around and goes back down. Pause the video and think about that for a while. The second derivative gets us what we call our points of inflection. And that's by taking the second derivative, setting it equal to 0, and solving, we would get these points here, which on our graph are the gold points. Now, what are the points of inflection? The points of inflection are the points in which the concavity changes from concave up to concave down, or concave down to concave up. Now, what does that mean? If I had my purple marker here, which I don't, if you look at here, this here is concave down, because this U shape, or almost like a parabola shape, it's facing down. That's what we call concave down. At this point, it changes to concave up, and it's going up. This is a upward concavity. This is downward concavity. At this point of inflection, the concavity then turns and changes, and it goes down. And you'll see some graphs where it doesn't. It might stay the same, or different things might happen. So this is more important than it looks on this graph. And it continues to stay concave down. This whole thing, from this critical point all the way to infinity, it stays concave down. It's only concave up between here and here. So those points of inflection gives us intervals of concavity. The intervals of concavity, so an upward concavity would be anything from my point of inflection, which we found on the other page, which was, where's my point of inflection? At 1/2 and -1/2. So at -1/2, to positive 1/2, I have concave up. And concave down, I have it concave down in two different spots. Actually, from negative infinity all the way to here, which is my negative 1/2, I am concave down. But also it's concave down from positive 1/2 all the way to positive infinity on the other side. So these are the intervals in which it's concave up or down. These are the intervals on which it is increasing or decreasing. And that's number 18 in your book. I suggest that you do this one over again and see how it goes. Next video, part 2, I'm going to do number 33 for you. Good luck.